So this is the introduction to hyperbolas, and so the first thing I really want to go over is the standard form for hyperbolas. Again, you don't want to get too much confused with the variables. So there is a technique again, as there was one for ellipses. So the standard form. So for the standard form, again, similar to ellipses, we have hyperbolas that are horizontal as well as vertical, and so we have this form x minus h squared divided by a squared minus y minus k squared divided by b squared is equal to 1. And then the other one would be y minus k squared divided by a squared minus x minus h squared divided by b squared is equal to 1. And so you don't want to get too much confused again with the variables. So what I have here is I have something that's really similar to the form you saw for an ellipse. Again, the major difference I would say is this subtraction sign. Again, you always want to remember that there's a subtraction sign for a hyperbola. And you see that this type of conic is also being classified as horizontal, which is this one, and vertical, which is this one. Now the major thing is that in the other one you saw that the a square and the b square were switching, right? And really you were able to know if it's a horizontal or a vertical depending on the position of a square. If a square was below the y, then you knew that that was vertical, and if it was below the x, then you knew that was horizontal, right? Because a is it's the larger value, and 2a is the length of the major axis. But here we're not looking at that. A squared and b squared, we don't say that a is greater than b or b is greater than a. There's no rule that states that. Rather, we're really looking at how it's positioned. So when I say positioned, I mean that the x minus h squared divided by a squared here is first. Here, y minus k squared is first. If you see the y minus k squared first, then know that it's a vertical hyperbola. If you see the x minus h squared first, then know that it's a horizontal hyperbola. And again, you probably understand that x, the way to remember it is x being the horizontal, x-axis being horizontal, y-axis being vertical, so vertical. So that's just easy to remember. Just know the order of whether x minus h squared comes first or whether y minus k squared comes first. And so these are the forms that you want to know. And so if you want to copy it down, you can. Now I will just go over a sketch exactly how a hyperbola looks like. It's a little bit different than an ellipse for sure. So you have your axis here, and so when we're graphing a hyperbola, you really have something like a box that forms. So you have like a box here, right? And you have this point over here, right? And then you have another point that's here, right? Or this could be here and this is here. And you have, so obviously this is your center point, and this would be your B, and this would be your A, right? Again, we don't know whether A is larger than B or B is larger than A, but we know that this value over here is A. We say that because this specific hyperbola is a horizontal hyperbola. I mean, it's really, you can think of this as really anything, but it's a horizontal hyperbola. Therefore, I'm saying that because usually you write A here, right, and B. We don't switch the values, or we don't move the positions of A and B. And so because A is here, and we know that if x minus h squared here is first, right, we know this must be first. Therefore, this is a horizontal hyperbola because this is first. Now, the fact that this is first, and we have a here, right, so we're really just making the A as the distance from the center, right, up to this point here. And so that's A, going in that horizontal direction. Now, if you didn't have that, if you had y minus h squared here, right, and you had A here, then we would have said this is A and this is B. So it would have been the other way around. But here, the different thing here than an ellipse is that this part here is the vertex actually. This is the vertex. This is also your vertex, again, you would say more like your co-vertices, but this is your vertex, co-vertices. So these are your vertices. Now you may be wondering where your foci or your focus points are. So the foci will be actually outside that box. So they're outside. So this is your focus, and your focus is outside here as well. So your focus are outside actually. And when you graph this, right, you have something like more like an I guess you could say asymptote, right? You have your asymptotes here, and when you're graphing, really your graph will look something like, it's gonna hit the vertex again, because vertex is a point on the hyperbola, and it's gonna go something like that. And similarly, this is a point, so you will have something like that. So this is just a sketch of how a horizontal hyperbola may look like. Again, when you're finding, because obviously when we were looking at ellipses, you saw that the focus was actually inside, right? However, in this one, the foci are actually outside the box, right? They're beyond your vertex. Therefore, the formula here does change. As I was saying, a squared is equal to b squared plus c squared applies for an ellipse. However, for a hyperbola, right, you're the foci, right? When you're finding the points of the foci, that is a squared plus b squared is equal to c squared. So more like the Pythagorean theorem, and you know that c must be the greater value because obviously it's that distance from the center to your focus point. So that is the value of c. So this is just the introduction to hyperbolas. I will be going over a sample problem in a later video. So thanks for watching.